In this video, we are talking about division and how to divide numbers. When we divide, there are 4 steps. Divide, multiply, subtract, and bring down. And when we bring down, we only bring down one at a time. So let's say we were going to divide 146 divided by 2. What I like to do to help me is just set up a ratio table of the multiples of 2. But your multiples can only go 1 through 9. So I'm going to set up a little ratio table right here. Ran out of space there at the end, but that's okay. Now you take your divisor, which is 2, and that's what you make the list of multiples of. So you have 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, it got pretty crunched in there. That says 16. Now you probably know your 2 times facts pretty well, so this multiples chart might not be as helpful on this problem, but when you're dealing with problems of numbers bigger than 2, especially if you don't know the multiples of it right off the top of your head, it really is helpful. So our first step is we're trying to divide 2 into 1 without going over. So we ask ourselves, how many times can 2 go into 1 without going over? Now 1 is below the line, so on my multiples list, I look below the line. And the first number I see is a 2, which is bigger than 1. So that tells me 2 can't even go into 1 one time. So it has to go into it 0 times. Now we take and we multiply that number that we just divided times our divisor. 0 times 2 is 0. Now we get to subtract. 1 minus 0 is 1. Then we bring down, and we only bring down one number, and we bring down the next number. So I've already taken care of the 1, so we get to bring down our 4, and this becomes 14. Now, as soon as I bring a number down, I have to start my steps all over again. So I'm going right back up here, and I'm dividing. This time, I'm asking how many times can 2 go into 14 without going over? 14 is below the line, so I look down here, and I can actually get right on 14. So I look above it, and it is 7 times. 7 is above the line, so I write the 7 up here above the line. Now I multiply my 7 times my divisor, which is 2, and we already know what it equals because of our multiples chart. Sorry, I want you to be able to see that. 7 times 2. And we already know what it equals because of our multiples chart. 7 times 2 is 14. Now that I have multiplied, I can subtract. 14 minus 14 is 0. And now I get to bring down my 6. And if I bring a number down, I have to start my steps all over again. So I have to ask myself, I have to divide again. How many times can 2 go into 6 without going over? So I look down here, there's 6. 2 can go into 6 3 times. Write my 3 up there. Now I multiply my 3 by my divisor, which is 2, and I get 6. Now I'm going to subtract, and when I subtract, I get 0. Let me zoom this out just a little bit so you can see it all. All right, when I subtract, I get 0. There is nothing else to bring down from the dividend. There are no remainders, so my answer is 73. All right, now that's a good problem just to review the basic steps. But it's not very often that we have a small divisor like 2. Generally, our divisors are a little bit bigger. So let's talk about what to do when that happens. So if I was dividing let's say 9,470, I'm trying to decide what I need to divide it by. Divided by 8. Okay, 9,472 divided by 8. This is called my dividend. 9,472 is the dividend. This is my divisor. So I need to set up my problem. The dividend always goes on the inside of my division bar. So I'm going to set it up right underneath it, and then I'm going to erase that. 9,472 divided by 8. Now I can erase all of this. Okay. Now I like to, before I even start dividing, I like to create a list of my multiples. I like to make a ratio table of the multiples. I'm going to move this over here just a little bit so I've got more space for my multiples. So I want you to pause the video, make a list of the multiples of your divisor, which is 8, 1 through 9. And then go ahead and try solving this problem. If you know how to do it, divide it. So pause the video, solve the problem. All right, here's my list of multiples of my divisor. The divisor is 8, and I've listed my multiples 1 through 9. You cannot go past 9 in long division like this. So now I can go ahead and start my steps. My first step is to divide. I'm asking, only look at the first number. How many times can 8 go into 9 without going over? So I look at my multiples chart. Well, 8 is less than 9, so it can go into it 1 time. Now I multiply. 1 times 8 is 8. I can subtract. 9 minus 8 is 1. I can bring down that 4. And as soon as I bring down a number, I have to start all over. So now I'm asking myself, how many times can 8 go into 14 without going over? So I see 8, 16. 16 is too much. So it'll be 8, which is again once. And I multiply my 1 by my divisor, which is 8, and I get 8. Then I subtract. 4 minus 8, I can't do it, so I have to borrow. 14 minus 8 is 6. And now that I have subtracted, I can bring down my 7. So I've got 67. I brought a number down, so I have to start all over, dividing again. So I'm asking, how many times can 8 go into 67 without going over? So I see 56, 64, 72. 72 is too much. 64 is as close as I can get without going over 67. So I take the 8, write the 8 up there. Now I multiply the 8 by my divisor, which is 8. And looking at my multiples, I already know 8 times 8 is 64. Now I subtract. 7 minus 4 is 3. 6 minus 6 is 0. Let me back this up a little bit. Sorry about that. All right. So I subtracted and I got 3. Now I need to bring down one number, which is 2. I brought a number down, so I have to start my steps all over again. How many times can 8 go into 32 without going over? So I look, and I can actually go into 32, which is, you can't see it, but it's 4 times. So I'm going to take and write my 4. here. Now I have to multiply the 4 times my divisor, which is 8. And I get 32. Now I subtract. And I get 0. There's nothing else to bring down. I have no remainder. So my answer is just 1,184. Okay, I'm going to give you a new problem. I just moved that over there, so I had a little bit more space to work over here. I want you to divide now let's do a little bit bigger divisor. We were only doing divisors that were single digits. This time we are going to divide by 12. That will be our divisor. All right, I want you to divide 3,780 divided by 12. First step, set up the problem, then create your ratio table of the list of multiples of the divisor. Our divisor is 12, and then go ahead and start dividing. So pause the video, solve the problem, and then you can check your work against mine when you click play. Okay, I just want you to take a second, check your multiples against mine, because if you get off on even one multiple, it'll throw off the rest of your problem, and you won't get it right. So just take a second, check your multiples, and if you need to fix any, pause the video and fix them. And if you got the multiples wrong, and that means you need to redo the problem, that's fine. Click pause, redo the problem. But I'm going to start dividing. So first step, divide. So I ask myself, how many times can 12 go into 3 without going over? Well, 12 times 1 is already 12, so we know that's too many. So I'm going to put a 0. Now on this one, I'm not going to use all the different colors of markers, just for sake of time. So I divided, now I multiply. The 0 times my divisor, 0 times 12 is 0. Now I subtract, 3 minus 0 is 3. Bring down one number, which is 7. And now I've got 37. I brought down a number, so I have to start over with my division process, and I'm going to ask how many times can 12 go into 37 without going over. So I'm looking at my multiples chart. I see 36. 48 is too much, so I know it's 36, which is 3 times. So I write the 3 up there. Now I multiply. 3 times 12 is 36. After I multiply, I subtract. It's 1. Now I bring down one number, which is 18. Or which is 8, so now I'm looking at 18. I brought down a number, I have to start all over. How many times can 12 go into 18 without going over? 24 is too much, so just once, which is 12. Now I multiply this by my divisor. 1 times 12 is 12. Now I subtract. 8 minus 2 is 6. I subtracted, so now I get to bring down my 0. I brought a number down, so I have to start all over. So I'm dividing again. How many times can 12 go into 60 without going over? I look on here. And 12 can go into 65 times without going over. So I put the 5 up there. 5, now I multiply. 5 times 12 is 60. After I multiply, I subtract. There's nothing else to bring down. There is no remainder, so my answer is, my quotient is 315. All right, I want you to do one more problem. 6,745 divided by 33. I know that's a huge divisor. It's bigger than any that we've done so far, but you need to practice dividing with bigger divisors. My recommendation is only take your multiples chart as far as you need to when you solve the problem. And I'll explain that when I solve the problem. But I want you to go ahead, pause the video, solve it, and then click play when you're ready to go. Don't forget to do your multiples though. That helps a ton. All right, now you can see I've started my multiples of my divisor, which is 33, but I haven't gotten very far. In fact, I've only gotten to 1. I'm going to show you why in just a second. creating the multiples of 33, that's a lot of numbers to be dealing with. So if I don't need to go all the way to 9, I'm not going all the way to 9. So I'm going to start my division. How many times can 3 go into 6 without going over? Well, 1 time is already too much, so I know it's going to be 0. After we divide, we multiply. Take the 0, multiply it by the divisor of 33. We get 0. Now we subtract, we get 6. After we subtract, we bring down just one number, and I'm dealing with 67. Now I have to start my process all over and ask myself, how many times can 33 go into 67 without going over? And this is where the ratio table comes in. 33 doesn't seem enough, so let's go to 2 times 33. And I can just add it. Or I could just do 33 times 2. Either one. I'll still come up with the answer of 66. And I can already tell by looking at it that that's as close as 33 can get to 67 without going over. So 33 can go into 67 2 times without going over. Now I have to multiply 2 times my divisor of 33, which is 66. Now I subtract. 7 minus 6 is 1. 6 minus 6 is 0. Now I get to bring down just one number, which is 14. And I have to start my process all over again. Once you bring down, you have to divide all over again. How many times can 33 go into 14 without going over? Well, 33 times 1 is 33, and that's already too much. So I have to put a 0. 0 times 33 is 0. Subtract. 4 minus 0 is 4. 1 minus nothing is 1. I just subtracted. Now I get to bring down. And because I brought one down, I have to start my process all over again. How many times can 33 go into 145 without going over? And I look at my multiples chart. I've got 33, 66. 66 isn't anywhere close enough, so I'm going to have to keep going. And I like to just add 33 every time. If you like to multiply it, that's fine. It still works. 6 plus 3 is 9. 6 plus 3 is 9. So 3 times 33 is 99. And 99 still doesn't seem close enough, so I'm going to see what 4 times 33 would be. So I'm just going to add another 33 onto my 99. 9 plus 3 is 12. 1 plus 9 is 10, plus 3 more is 13, which is 132. That seems like it's close. Let's just go one more just in case. Going to add another 33. 2 plus 3 is 5. 3 plus 3 is 6. 1 plus nothing is 1. So I have 165. Now I can definitely see that 33 can go into 145 4 times without going over, because 132 is as close as I can get without going over. So I take my 4. Now I have to multiply the 4 times the divisor of 33. 4 times 33 is 132. And I have to subtract. 5 minus 2 is 3. 4 minus 3 is 1. 1 minus 1 is 0. Now in this problem, there's nothing left for me to bring down, but I do have a remainder of 13. But because I've done my work correctly, I'm not too worried about it. I would just have to read the word problem that I was trying to solve to know what to do with my remainder. But that's how you divide. If you have any questions, let me know.